for CIN708. Okay, few reminders. Please do note that your critic writing, your critic assessment is already due. Yeah, it's already due. And the due date was on the 1st of September. Now, there are few who are yet to submit. Your cutoff time is on the 6th of September. So you still have somewhat like 3 days to actually go and submit your assessments. However, it comes with certain amount of deduction. Okay, so please do ensure that you are submitting all your assessments. If you haven't submitted now, it's better to get something rather than nothing for your critic writing. Your mid-semester exam, it begins the upcoming Sunday, 6 a.m. and you have 8 days of time, and it closes off on the 12th of September. Do feel free to go around and have a look at the structure of how the structure and the format of how your mid-semester exam will be, and prepare yourself very, very well. Now, next week, we will not be having any lecture or tutorial class. So what we will be doing instead for our lecture and tutorial is that I will be giving you out some sample revision questions. Now, I do understand that the tutorial class is on Friday and your exam closes off on Sunday. So you have very little as 2 days time. Moreover, or however, you have your lecture class, which is on Wednesday evening. So in the Wednesday afternoon or evening, somewhere around that time, what I will be doing in the class is that I will give you sample questions all the way from lecture 1 till lecture 5. And you are supposed to answer the questions yourself. You have to work towards it, remember. I will give you the questions. You'll have to find out the answers and then use them as a revision guide for your mid-semester exam. The coverage is all the way from week 1 till week 5, inclusive of the lecture-based quizzes, and also inclusive of all the tutorials and lecture notes that we have discussed so far. So yeah, so those are the reminders on mid-semester exam, your critic writing, lecture-based quizzes. Okay, there's some way or the other, I've realized that students are not fully attempting the lecture-based quiz. Okay, there are those who are yet to even attempt week 1 lecture-based questions. Now, the good thing is it's valid, or the lecture-based quiz, the due date is on the 31st of October. Okay, but if you're not answering the questions now, so you are missing on to your MST revision. So please ensure to attempt your lecture-based quizzes. If you want to answer it somewhere close to 31st of October, it's completely up to you. There's no stopping to it. However, you are on the losing end, because I am testing you some questions based on lecture-based quizzes as well. So that's on the basic reminders. Okay, so lecture 5 was basically on the essentials of information systems, especially the infrastructure and the sustainability of information systems. And based on that, we had our tutorial questions. Now, in our tutorial 5, questions 1 to 10, those were the questions that you were to attempt in the tutorial discussion forum. Those who have already submitted, I have provided you with the sample answers already. Those who are yet to submit, please do submit them. Only then you would be getting the sample answers, else you aren't. So without taking much time, let's go and discuss our tutorial 5. I hope you are able to see the screen displayed in front of you. So our tutorial 5, okay, these are the questions 1 to 10, simple questions, not so difficult. Okay, direct lift off from the notes. So if you are referring to the notes while attempting the questions, you should be able to answer most of the questions directly from the notes. So next up, we have critic writing. So we have 2 questions on critic writing, so very small ones, and based on that, we are supposed to draw conclusions or critique about it. First one, universities are switching to Gmail. Let's read it out. Okay, schools around the world are moving to cloud computing applications such as Google Docs and spreadsheets and Google Calendar. By the way, when you're referring to cloud computing applications, these are more so something like this, whereby you are using computing services which are not physically located right in front of you. They are at a far location than where you are, and through the use of internet technologies, you are able to use these services. Yale University had planned to move from its own email system to Gmail or Google Mail, but at the last minute decided to cancel the project because school administrators and faculty members did not believe the move could support their business requirements. Do you agree or disagree that Google Gmail would be unable to replace a university's private email system? What are the advantages and the disadvantages of a private email system? What are the advantages and disadvantages of using a cloud application such as Google Gmail? What choice would you make if you were the primary decision maker for selecting your school email system? Now, the answer here can be in both the categories, whether you are in favor or you're not in favor. So I will not be simply telling you the answer whereby whether I'm in favor or I'm not in favor, but we'll go and have a look at it in overview. Okay. Now, so far the situation in the critic is this is what happening. So this university, Yale University, they wanted to move their private email system, the university's email system, into a Google Mail account, which is Gmail that we generally call it as. But in the last minute, they pulled off from the deal and they canceled it because the school administrators and the faculty members did not basically believe that it would meet the requirements of the university. So based on that, you are supposed to say whether you agree or disagree. Now, I will be giving you a general overview of what the issues surrounding maybe and what would be favorable in for Gmail, and based on that you can make a conclusion whether you support the idea of having an of university having a Gmail account for replace their private email system or not. So overall, probably you can write this down. I will dictate. Okay, the biggest issue with Gmail would include, please do write this down. You never know, this might be tested in your exams. The biggest issue with Gmail would include the biggest issue with Gmail would include feeling of insecurity. The biggest issue with Gmail would include a feeling of insecurity surrounding the mail systems. Surrounding the mail systems. Full stop. With a private email system, comma, with a private email system, comma. So when we say private email system, is just like the university having their own email system. Okay, so with a private email system, comma, the business would have total control. The business would have a total control over the system's operations. Over the system's operations. Over the system's operations, comma, including backup and security measures, comma, including backup and security measures. Full stop. When using Gmail, comma, all these features would be out of their control. All of these features would be out of their control. Full stop. All these features would be out of their control. In other words, what we're actually writing down at the moment is the biggest issue related to businesses using Gmail as their email system is the feeling of insecurity. That means there's always a feeling that the data is not secure. So when a university in this case, or a business in one way or the other. So if a business is having a private email system, they have total control over its operations. They have total control over the data that they back up. They have a total control of all the security measures. So if this particular university in this case, if they use Gmail, so all these features of total operations, backup security measures would be totally out of their control. Now, can you add just one more sentence to it? With all cloud computing applications, comma, with all cloud computing applications, comma, you are giving up an element of control. You are giving up an element of control as the system owner is responsible. You are giving up an element of control as the system owner is responsible for availability, comma, reliability, availability, comma, reliability, comma, scalability. Scalability spelling is Scalability, scalability, etc. Full stop. This can be overcome by simply This can be overcome by simply educating the business about the This can be overcome by simply educating the business about the security measures that are deployed. This can be overcome by simply educating the business about the security measures that are security measures that are deployed in a cloud application. Full stop. Deployed in a cloud application. Full stop. So the last line, what we're saying is, now all these security issues, all the issues related to backup, or general operations, availability, reliability, and scalability, they could be overcome or they could be dealt with. And the way in which these could be dealt with is simply educating businesses, and in this case, Yale University, about the security measures that are deployed in cloud application. When we say security measure, it simply means is that even though we think things are completely online, the data is not safe, well, there are security measures. And also, if you are hosting a process like an email system on a public cloud, Gmail is a public cloud, on public cloud, security measures can be implemented accordingly to ensure the data is safe and sound. I'll give an example. If you use a student email, you you know, FNU has used a public cloud email system. We've used Gmail. So your emails, especially your student emails, they're all stored on Google's server, and there are good set of security measures that can be used. So in this case, which one is preferred, whether to have it to have the school's email system on Gmail? So in this case, to make a conclusion to whether have the Gmail system used for the university's own email system or not, it yes, you can use it. Why you can use it? Because there are adequate security precautions and measures taken in so that your data is safe. And if you say that the Yale University should not, then you can also say that since it is off, the data is out of the organization, is hosted elsewhere, probably in another country. So in that case, what will happen is you can say the data is out of their control, the operations is completely out of their control. So the answer totally depends on what you put in as, but you have to back up with adequate answers or reasons. Now, moving on. Your next critical writing. Now, e-waste and the environment. By some estimates, there may be as many as 1 billion plus or obsolete computers and monitors in the world. Obsolete, those which are about to phase out, those which are not being used. Consider California, where 6,000 computers become surplus every day. Now, we're not talking about year, but we're talking about every day. Why so many computers? It's just because technology is way more advanced in countries like the United States. California is a state in the United States. Okay, so probably that would be one of the reasons. Moreover, new technology keeps on coming in every now and then. Okay, also do note that technology in those countries are way more cheaper, and the income level of individuals are way more higher as well. So their affordability rate of actually purchasing these kind of technologies becomes more and more, yeah. So they have more affordability rate, so they buy more items, computing items. Now, 6,000 computers surplus every day. If not disposed of properly, this enormous e-waste stream, now e-waste, the definition of e-waste is in your lecture notes as well. Basically, we're talking about electronic waste, especially in terms of electronic devices, which can contain, I'm here, which can contain more than 1,000 toxic substances, is harmful to human beings and the environment. Okay, so like I mentioned in our lecture notes, okay, so our computers, they contain a lot of toxic materials. Okay, so if they are left exposed, if they are burned, or they are exposed to massive heat or massive wet conditions, okay, what might happen is it will release some sort of toxic substances into the environment, which can affect humans as well. Now, beryllium over here, it is a chemical that is generally found in metals. Now, beryllium is found in computer motherboards, chromium in floppy disks. Chromium comes from the word chrome, lead in batteries, you know what lead is, and computer monitors, and mercury in alkaline batteries. One of the most toxic chemicals known as cadmium, okay, also again, it is a chemical, okay, cadmium rather, found in many old laptops and computer chips. In poorer countries, where the United States and Europe export some of their e-waste, the full impact of the environment damage is quickly being realized. Okay, so from this, we also know, I just came to know just after reading this, critic question is that the United States and Europe countries, they export their e-waste, that means they dump off their e-waste in certain countries, okay, especially those countries which are very poor in terms of financial status. So for dumping the waste, so the country is paid certain amount of money. These areas have little use of obsolete electronic equipment, so local resellers resell some parts and ban the rest in illegal dumps, often near residential areas, releasing toxic and carcinogenic substance into the air, land, and water. Now, the term carcinogenic comes from the word cancer. Okay, so these materials which are burnt off, okay, and since they would be dumped off in certain areas and exposed to heat or cold temperatures, it releases these toxic materials which has carcinogenic substances, and they have a likely chance of potentially causing cancer to human beings. Now, omit this 18, okay, it should be there. Have you ever participated in e-waste? That means, have you ever dumped electronic waste somewhere? What do you do to ensure that you are safely disposing of electronic equipment, including batteries? What are what can governments do to encourage companies to dispose of e-waste safely? What can be done to protect poorer countries from receiving e-waste? Create a list of ways you can safely dispose of cell phones, computers, printers, ink cartridges, and batteries. What could you do to inform citizens of the issues associated with e-waste and educate them on safe disposal practices? Now, there are some potential things that we could do, okay, and namely, there's a lot of things we could do, okay, to handle e-waste. I've got few things over here out of the many things, many possibility of things. If you also have certain idea, and if you feel I have not called it out while I am issuing the answers, you are most welcome to unmute your mic and speak, and you can share it with the rest of the class. So some ways in which we can, dump off, or some ways when we can manage e-waste properly is one, recycle and reuse. You can write this down, recycle and reuse. Now, why recycle, reuse? You use computing devices. You can reuse parts in computing devices. You can recycle some parts, okay? And moreover, you can also distribute these devices which are still working to individuals who do not have access to even the basic ones, okay? So first one is recycle or reuse. Now, there was a question on how can governments play a big part. Now, what governments could do is, you can write this down, governments can come up with e-waste policies. Governments can come up with e-waste policies. Just like we have in Fiji for the plastic bags, you can also have something for e-waste materials. Third thing that the government could do is, the third point is government can ensure, you can write this down, government can ensure that these e-waste materials and devices can be reused. Full stop. Fourth point, governments can invest into manufacturing or industrial businesses, which can use and produce other products, write down, which can use e-waste materials, and produce other products. Full stop. Now, a very good example is what our local government has done with plastic bottles. Okay, so many instances, the plastic bottles, they are collected. Okay, even the glass bottles, the beverage glass based bottles, okay, they are collected and people are paid certain amount for collecting it and handing over to the suppliers, and these are given back to the manufacturers at a certain price, and they refurbish it and reuse it. Okay, now with plastic bottles, you must have seen plastic bottles, people generally use it for either using it for water bottles, or they use it for planting and stuff. They use it for decorations, they're using it for gardening and so forth. Okay, now some of these materials can be used something as such as well. So it all depends the initiative that comes up from the common day citizens and also the government. And finally, okay, another thing that could be done to have to have good knowledge about e-waste is to educate people. Write it down, educate people. Put on a dash or hyphen. Educate people on dash effects, 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 comma, reuse, comma, recycle, and finally, manufacturing other products. Full stop. Now, if some way or the other people are educated about the effects of these e-waste. Now, how many of you already knew that just by dumping off your computing devices in the environment, it can cause cancer? Very little people know about such things. How many of you knew what beryllium was? How many of you know what was carcinogenic was? Okay, so these are some of the chemicals that are released when these e-waste materials are dumped off into the environment, and they can cause a lot of serious health issues. So if people are educated about these things, they would not dump it off anywhere and anyhow. Moreover, people, if they are educated how to recycle and reuse these materials, then they'll go ahead and recycle them. And also, if they are educated in terms of how to use these materials and produce other products and services, people will always go and try to produce these things and sell it off to other individuals and make money out of it. Okay, so these are some of the things that needs to be catered when we are dealing with e-waste technologies. So if you e-waste technologies and materials, so do you have any answer over here which I have missed on to? You feel you have an answer and that could be discussed in the class? If you do, I'll give you a minute or two to share your ideas with us. Okay, none. If not, let's continue with the case study. Now, the case study for today is on the co-founder of Intel. Now, Intel is a large company in the United States. What does Intel actually do? They produce microprocessor chips. Now, microprocessor chips, that generally in computing terms, when we talk about microprocessor chip, we say it is the brain of a computer system. A microprocessor chip generally does processing for a computer. So without it, your computer does not have the ability to think or ability to process input and produce output. So Murray, or Gordon Murray, he is the co-founder, one of the founders for Intel. So let's go and read these things. Now, Murray's law is dead. Murray's law is named after Intel co-founder Gordon Murray. He observed in 1965 that transistors were shrinking so fast that very year. Twice as many could fit onto a chip, and in 1975, he adjusted the pace to a doubling every 2 years. So Gordon Murray in 1965, he observed the microprocessor chip, also called as transistors back then. So these transistors used to be huge in size, probably the size of a particular page, that size, the A4 page, or probably bigger than that. Now, over time, and if you compare an A4 page size, and have you seen a memory stick, very small one, SD, probably micro SD, or the size of a SIM card? That's how big the current microprocessor is. Okay, so what Murray had observed that these microprocessor chips, the sizes were decreasing or shrinking very fast every year. So what he predicted and said was every 2 years, okay, the size of the chip will become more and more smaller, and computers and their processing capabilities would be double the speed. Let's read on. The chip industry has kept Murray's prediction alive, with Intel leading the charge. So his own industry has been doing something as such. And computing companies have found plenty to do with the continual supply of extra transistors. Transistors and microprocessor chip, same thing. Mobile apps, video games, spreadsheets, and accurate weather forecasts. That's just an sampling of the life-changing things made possible by the reliable, exponential growth in the power of computer chips over the past 5 decades. Fairly true. Okay. Now, over the past few years, Okay, video games previously used to come in form of cartridges, and then later onwards they started coming in the form of CDs or DVDs, and then now it's as simple as playing a video game in a mobile phone. Spreadsheets you could only use previously you could only use spreadsheet in a desktop computer. Then it came into a laptop. Then it came into a tablet. Now you can use your spreadsheet in as small as of a screen of a mobile phone. Okay, and weather forecasts previously weather forecasts used to be told in the radios or in terms of television broadcasts. Now you can get it just online through the use of your mobile phones or to the use of the internet. Now this is all the work of a computer chip. How? Because the computer chip is the main functioning body that enables your hardware devices to run efficiently. When I say hardware devices, all the physical devices, your computers, your mobile phones, these are all hardware. So each of them have a computer chip associated to it. But in a few years, technology companies may have to work harder to bring us advanced new new use cases for computers. The continual cramming of more silicon transistors into chips, known as Moore's law, has been the feedstock of exuberant innovation in computing. Now it looks to be slowing to a halt. The past or the last few years have shown a stagnation on chip development, and that is bad news for research programs reliant on supercomputers, such as efforts to understand climate change, develop new materials for batteries and superconductors, and improve drug design. Now, what has happened is lately in the past few years, the continuous growth of computer chips. Now, when we talk about growth here, it means making it into more smaller size or making the chips work faster. It has come to a stagnant, slow pause. Why? It's just because it has reached its maximum speed. Okay, or even if new computers are coming in with more speed, okay, but the growth is not as fast as what Moore's law was actually indicating. That means it's not doubling up. Intel recently pushed back its next transistor technology and has also decided to increase the time between future generations. And a technology roadmap for Moore's law maintained by an industry group, including the world's largest chip makers, is being scrapped. Intel has suggested silicon transistors can keep shrinking only for another 5 years. Okay, so that means the size of the chip can only go till the next set of 5 years. Now, this book was written somewhere around in late 2018 or 2019. So that means by the next few years, year or 2 years or 3 years time, okay, the speed of the microprocessor will come to a halt. Now, do you know what do we talk about when we say the speed of microprocessor? Let me show it to you very, very quickly. Let's have a look at this. Okay, let's say you have a computer. Okay, so what you'll do is, now generally we had an option previously called my computer, but my computer doesn't exist anymore, but instead we have this PC in all Windows-based computing systems. To actually check what is the processor speed of a computer, so in this PC particular window, you'll do a right click and then click on properties. So when you click on properties, it will display you a set of system stats about your current device, in this case my laptop over here. So if you look at processor, now the processor has to do with what we're talking about, the transistor chips. So processor is Intel Core, see, developed by the company called Intel Core. It's i5, that means it has 5 processors, okay? And moreover, the speed is 1.6 gigahertz per second to 1.8 gigahertz per second. Now, what it simply means is this is the speed at which the computer is able to process all the processing that needs to take place. Now, this is quite low compared to high-end devices, because with the latest high-end devices, the speed is close to about 2.3 gigahertz to 2.4. Now, what happened previously, we had the speed in terms of MBs. So kilobyte, megabyte, gigabyte, terabyte. So it used to be in MBs, and very quickly within the past decade, it has moved from MBs into from megabytes to gigabytes. Okay, and then it very quickly went from 1.0 to 2.3 and 2.4 gigahertz. Okay, gigahertz is just like processing it in millions of processes at a time. So now after 2.4, we do have computers which has come to 3 gigahertz per second, but over time that growth has become more and more slow. Why? Because that is a limit to which technologies can grow, and to actually make it go beyond it, so companies like Intel, they need to start they need to come up with new things, new sense of technology, new transistors, and so forth. So where were we here? Mobile devices are powered by chips made by companies other than Intel, and they've generally been slightly behind in transistor technology. Now, why behind? Because with mobile devices, when we talk about mobile devices, we're talking about mobile phones, smartphones, we're talking about tablets, we're talking about laptops as well. Laptops also come under mobile devices. That means you can easily carry it around. But generally, it says here, okay, they have been slightly behind in transistor technology. Why? Because overall, these devices are small. So if you want to have a device which has very large processing capabilities, the device needs to be large as well. So desktops are way more faster in some cases instead of laptops. Okay, this is what it's trying to say. However, many useful things that mobile devices can do rest on the power of billion-dollar data centers, where the end of Moore's law would be a more immediate headache. Companies such as Google and Microsoft eagerly gobble up every new generation of the most advanced chips, packed more densely with transistors. Alternative ways to get more computing power include working harder to improve the design of chips and making chips specialized to accelerate particular crucial algorithms. In simple words, what he's saying is there are some companies which basically go and try to put up many different chips together, or many more than one chips together. For example, this particular laptop that I was showing you, it's i5. That means there are 5 chips in one of these computers. In one of this, in this very laptop, it's just a single laptop, 5 chips, 5 transistor or microprocessor chips. So that allows the computer to function faster. Now, we have technology whereby instead of i5, we have i7. So i7 has 7 of those chips in one particular device. We also have i9 now. So i9 is whereby 9 chips are in one device. So what it does, it allows the device to process things in the computer system even faster. Okay, so that's what it's talking about. The coming plateau in transistor density will stir more interest in redrawing the basic architecture of computers among supercomputers and data center designers. Now, supercomputer, we're talking about a very, very large computer, and it has very, very large memory, very large processing speed, and also moreover, very large storage space. Now, supercomputers, where are they used? These computers are generally used for very high tech work. For example, NASA, used in NASA. They may be used in highly medical research work, or highly medically or machine operated hospitals. Okay, so that's where supercomputers are used. And data center is basically a facility whereby all the IT equipments or devices are based. Getting rid of certain design features dating from the 1940s could unlock huge efficiency gains, yet taking advantage of those would require rethinking the design of many types of software and would require programmers to change their habits. Now, what it simply means here in the last paragraph is we can go around tracing back all the way down to 1940 and changing things in a different way compared to what it has already been done. However, what it will do is if things are changed, so the advancement that we have now, it may not occur. So that is what it's trying to say. Now, questions. Question number one, do you agree or disagree that Moore's law is coming to an end? Now, this is a simple answer, okay? And this is where we can answer it verbally or we can just answer it simple terms, okay? So do you think, is it coming to an end? I feel yes, it is coming to an end, but on the other side, it's technology. Somebody in one way or the other will come up with something that will give a new way of looking at things in the technological arena. In other words, who would have thought that that in early 1991 we would have a technology called something as the internet. Now, previously, the internet, when it came up, and with it came up the very first website. So what it was used for was it was used within an organization whereby people viewed the web pages within an organization to go around and send communication or pass on messages to one another, communicate with one another, or share materials, electronic materials in terms of book notes and so forth with one another. But then in early 2005, it came to a sudden boost. And early 2006, we had something called as, which we now look at a very good and sort of entertainment in our life. Something came up called as Facebook. Okay. And I think Facebook came and changed almost everything about the internet. Now, people previously, they were used to Google, they were used to Gmail, they were used to Yahoo or Gmail messengers, but Facebook came in, Viber came in, Instagram came in and changed the game altogether. But even though just looking at the or reading this particular case study, it seems that Moore's law has come to an end or is about to come to an end because technology is slowing down now. But here's another thing, somebody in one way or the other will come up with something new. Now, I don't know if you would actually be knowing this or not, but universities all throughout the world and also universities here in Fiji, including Fiji National University, we have researchers who research on these things and they try to come up with new things, not only in terms of technology, but everything around the environment. Okay, so someone in one way or other will come up with something and Moore's law would again be proved as it is still running. All right, so the answer totally depends on what you write here. If you say agree, you have to come or you have to give your reasoning. If you say disagree, you have to give your reasoning yet again. So question one, I'll leave it to you how we'd like to answer it. Question number two, what will happen to the business environment if Moore's law does die? Okay, over here, this is where you write the answer. Okay, I'll dictate and you may write, so please write down. Now, if Moore's law does die, comma, if Moore's law does die, comma, businesses would use the current technology. Businesses would use current technology and try to integrate or converge them and try to integrate INTEGRATE or converge them, CONVERGE. By the way, integrate or converge, that means you join something together. So technological convergence is whereby you try to mix up the features of many devices into a single technology. Okay, so businesses will try to integrate and converge technology to come up with something new, to come up with something new. Full stop. Moreover, comma, moreover, comma, researchers and scientists, moreover, researchers and scientists would continuously work to advent, IDVENT, to advent new technologies. To advent, IDVENT, to advent new technologies. Advent means to come up with. Okay? Advent new technologies. Full stop. Also, comma, machine learning and artificial intelligence machine learning and artificial intelligence may begin to take over business processes. Full stop. Question number 3. What can companies do to remain competitive when hardware advances are not driving companies forward? So the answer here relies on what we have been learning all throughout in CIN708. And the answer is customer service is a big driver of the information age. Customer service is a big driver of the information age. Full stop. Businesses will heavily rely on information. Full stop. Businesses will heavily rely on information. Full stop. These information will enable businesses to come up with competitive advantage strategies. competitive advantage strategies. Full stop. So in other words, okay, if such things like hardware advances or latest hardwares in the computing field, if they come to a certain stop or they come to a very slow progress, so what businesses will start relying on is they'll start relying on information. So information about customers will be derived from the customers. So customer service, okay, through customer service, you will be able to derive information about customers. So this information will then be used to come up with competitive advantage strategies. And with those strategies, a business may remain competitive in the market. All right, so that finishes our tutorial for week 6. Any questions, any queries, anyone? Any questions, any queries? Okay, if no questions or no queries, so this is where we'll finish off the class for today. I think it's better when our classes are between 1 hour to 1.5 hours, because when it goes too long, it becomes too monotonous. And moreover, I do realize that there are many of you who have internet connections, so you go on and off Zoom. So if the classes are a bit smaller, between 1 to 1.5 hours, so most likely it's also easy for you to go and view the recording later onwards as well. So thank you for those who have joined in, and those of you who will be viewing the recording later onwards, thank you as well. Now, I do hope that you are preparing yourself well for your mid-semester exam, and also please take care of yourself and stay safe. Till then, let's meet up next week, Wednesday. Thank you, everyone.